This video is a project case study for San Jose State University's ME 110 class, Manufacturing Processes. We will go in depth into the manufacturing processes of a tattoo machine and discuss how some of the parts were made. The parts that we will be analyzing are the frame base, plastic grip, front spring, back spring, and washers. From inspection of the frame base, we determined that it was likely die-casted followed by bending. The evidence for these processes is the complex shape, smooth surface finish, and the 90-degree bends. An alternative process for this part could have been powder metallurgy. However, this process is limited in part size and complexity. Also, the initial investment cost is high and parts are prone to damage during the green state, which can additionally increase the cost. Die casting is a better process for this part compared to powder metallurgy because production is fast and it reduces or eliminates the need for secondary machining operations. Die casting also has better dimensional accuracy. The plastic grip was most likely manufactured by injection molding. The evidence of this process is the distinct parting line on the part. The hole through this part was most likely drilled, followed by reaming for a smooth internal finish. An alternative process could be casting. However, casting has a slower production rate. Casting also requires a machine finish which would increase the time and cost. Therefore, we believe injection molding is the most efficient manufacturing process for the plastic grip. It can generate high production volumes and the process has a low cost per part compared to casting.
The front and back springs were determined to be manufactured by stamping and punching of sheet metal. Evidence of this process includes the simple geometry of the part and the uniform thickness. Also, the smooth surface contour of the bend in the front spring is evidence of sheet metal processes. The washers were determined to be stamped from stainless steel. The evidence for this is the simple geometry, smooth to fractured transition of the edges, the raised surface from shearing, and thin uniform thickness of the parts. Alternative processes would be water jet cutting, laser cutting, or machining. We do not think it is any of these processes because stamping has better high production efficiency, it's more cost effective, and it's more easily implemented compared to machining, water jet cutting, and laser cutting.